We are given an m into n matrix containing positive integers including 0, and from this matrix we need to find out the longest strictly increasing path by moving in any 4 directions. That is, we can move up, down, left or right from each cell of this matrix. For example, this path of length 7 is the longest strictly increasing path in this matrix. One interesting thing about this problem is that since we can move in any 4 directions, there can be many paths from each cell of the matrix, and therefore there can be many overlapping paths as well. For example, take these 2 paths starting from the cell value 2. Here we can see that this part of the path, that is the path starting from cell containing value 6, is actually overlapping, and therefore we are computing it twice. Since in this problem there are overlapping and repeating subproblems, this problem is a perfect candidate for dynamic programming. So what we will do is, for each cell in the given matrix, whenever we are finding out the longest increasing path for each cell in the matrix, we will store the result in the corresponding cell of a new matrix for future use, and we will call this new matrix paths. For example, for the first cell 5, in order to form a strictly increasing path, we can only choose one direction, that is towards the right. So now the longest path from cell 5 is 1 plus the longest path from cell 6. From cell 6, we can only move in one direction, that is towards the right. So the longest path from cell 6 is 1 plus the longest path from cell 8. Now also from cell 8, we can only move in one direction, that is towards the right. So the longest path from cell 8 is 1 plus the longest path from cell 9. From cell 9, we cannot create any more increasing path. So we cannot move forward to any directions from here. So the longest path we can have for cell 9 is 1. Let's update it in the paths matrix. Accordingly, now for cell 8, the longest path is 1 plus 1 equals 2. For cell 6, the longest path is 1 plus 2 equals 3. And for cell 5, the longest path is 1 plus 3 equals 4. Now for cell 3, we can only move in one direction, that is upward direction. And we know that the longest path from cell 3 is 1 plus the longest path from cell 5. Since we have already computed the longest path from cell 5, we can reuse it. So the longest path from cell 3 is 1 plus 4 equal to 5. Now for cell 2, we can move in two different directions, upward and towards left. If we move upwards, in that case the length of the path will be 1 plus the longest path from cell 6, that is 1 plus 3 equals 4. And if we move towards left, in that case the length of the path will be 1 plus the longest path from cell 3, that is 1 plus 5 equals 6. Since we are looking for the longest path from cell 2, we will choose the left direction. So the longest path from cell 2 is 6. Now for cell 1, we can move in three different directions, upward, left and right. If we move towards right, then the length of the path for cell 1 is 1 plus the longest path from cell 7. Since we have not yet found out the longest path from cell 7, first we need to find that out. From cell 7, we can only move in one direction, that is upward. So the longest path from cell 7 is 1 plus the longest path from cell 9, which gives 1 plus 1 equals 2. And therefore now for cell 1, the length of the path taken through the right direction will be 1 plus 2 equals 3. If we have moved upward, in that case, then the length of the path for cell 1 will be 1 plus the longest path from cell 8, that is 1 plus 2 gives 3. And lastly, if we have moved towards the left, then the length of the path will be 1 plus the longest path from the cell 2, which is 1 plus 6 equals 7. Among these three, the longest path is 7. So since we are looking for the longest path, we will choose this one. And by the end of the iterations, we will have the longest path from each cell of the matrix. and we will choose the maximum among them and return it. Let's code the solution now. We need to find out the longest path from the matrix. So we will have this variable initially set to 0 and at last we will return it. For traversing through the matrix, we need to know the number of rows and columns. We will store it in these variables m and n. For storing the longest increasing path from each cell of the given matrix, we need to create a new matrix of the same size. We will fill it with zeros initially. Since we are allowed to move in 4 different directions, we can store these 4 directions in the form of arrays. So whenever required, we can simply add these to the cell indices. Now let's traverse through the matrix. We will find out the longest increasing path from the current cell and store it in this variable. For finding the longest path, we will write a separate function. This function will take the current cell indices and the previous cell value. The previous cell value is required because we need an increasing path, and therefore we need to check whether the previous value is less than the current value. So when we are starting a new path from any cell of the matrix, we can pass -1 as the previous value, because it's given in the question that the lowest number that can exist in the matrix is 0. So -1 is valid for creating an increasing path. In this function, we will find out the longest path and store it in the corresponding cell of the paths matrix. We know that the longest path is found out as 1 plus the maximum of paths we get from the 4 different directions. And we will return the result. Now in the beginning of the function, we need to put some checks. If the cell indices are out of matrix, or if the previous cell value is not less than the current cell value, in these cases we need to return 0. Also, if we have already found out the longest increasing path for the current cell, we can return the previously computed result, so that we need not have to repeat the computation. And during each iteration, we can check whether we have found out the longest path and update it accordingly. Let's run the program and check. It's working. See you in the next video.